We're back, so let's jump back into our Fabricator settings. And today we are going to be exploring the sheets and reports. I believe this will be a pretty quick video. We only have three categories: bill of material layout, sheet revision layout, and sheet loading settings. So let's just dive right into it. So let's start with the bill of material layout. This is where we're going to create our bill of materials. And by create bill of materials, I mean the order that we put things in the bill of material. So if we look here, you have your plot order. Your plot order is the order that it's going to be done. So what that's saying is in column 1, it's going to say line. In column 2, it will say quantity for the total, not the unit, the total. So the total is I have 52 beams. So in 4, it's going to say description. So the description is going to be like a W1835, a C12 by whatever. It could also say beam, column. 3 is your piece mark. So, line, then quantity. So 52, 36B, then W18 by 35, and then the length, which would be in feet and inches, unless you're using the metric system. 7 is the weight. 6 is your remarks column, and then you see how these say merge. So merge would be, so the minor mark is going to be merged with the piece mark. So you would see 52C, but then in the minor mark you would see the A51. But they would be in the same column. And then the same thing with grade here. Your grade, the way it's set up out of the box, is going to merge with your remarks column. If we want to change anything in here, it's really simple to do. Like say we don't want this line, I can just click it and go to hit the dash, and you see it's rearranged all the columns for getting rid of the line. If I want my minor mark in its own category, I can come in here and say I want it to be 3. So now it's going to go quantity, piece mark, minor mark, then description. So you just set this up the way the Fabricator wants it set up. All fabricators want to see things differently. We all know this, unless you're a brand new detailer. And if you are, welcome to the field. Don't let this work get you too stressed out. It can happen. So let's just take a quick look at this Fabricator's bill of material. Drag this over here so we can see it. So here you can see they want mark, which would be your piece mark, your sub mark, then the quantity, then the description, length, remarks, and grade, and then coatings and weight. So to set this up, I'm going to use what's called desk pins. That lets me lock my screen on, but now you can also see that I can't see anything behind it. So let's close this box, We're going to... Okay, so now we can see the bill of material. We can see our setup here. So, piece mark, we want to be 1. So we'll make this 1. And then we see that the minor mark is merged. So we will come up here and we will say merge. So now we have piece mark is 1. Our quantity is 2. Our description is 3. Length is 4. Remarks is 5, so they have grade. Grade is going to be 6. They have surface finish, which is down here, so that would be 7. And then weight would be 8. So let's just, in Bluebeam, we'll just click this tool right here that lets us count. So we're going to go 1, 2, 3, 4, 5, 6, 7, and 8. So there is our numbers, and you can see here if we follow through, we got 1, 2, 3, 4, 5 is the remarks, 6 is the grade, 7 is the surface finishes, which is also coating, 8 is the weight, and I don't want the advanced mill in there. So now we have this set up to match this Fabricator's settings or bill of material. So we say okay to save it. And if you noticed in there, there are multiple ones. Like if you're doing a report, you can set it up differently. Or you can even do, you can sort. I've never really used the sorting. I've never messed with the report 1, 2, 3 layout. We just stick with this first one, and any reports we're going to write, we custom write the reports. So sheet revisions. Same thing, let's just jump in and look at this Fabricator's. So here is their revision chart. So they want rev is 1, date is 2, and description is 3. So this one is already matching what they use. They don't put the user, whoever revises its initials, in their block. So it's fine the way it is. So disable the automatic creation of base drawings, disable the creation of archive drawings. This is turned on because the more base drawings you have, the bigger your job file gets, the slower it can get. And if you want a base drawing, you can create one without having this turned on. This is just disabling the automatic creation. Modify bill of material. I don't want, if I modify the bill, I don't want you to do anything to my revision. And to be honest, I'm going to do all my revision clouds and everything myself. You can set SDS2 up to do that, but I have seen some problems come from that. Like you put it on a sheet, you printed it, and then you realize there was a mistake. You go and you modify it, and now it's marking everything as revision, and you don't want that. So I do all my revisions myself. I don't want it to cloud anything automatically. I don't want it to automatically add something to my revision. So I leave everything just like this. This is the only area that I mess with. So we will say okay here. Now sheet loading. Sheet loading is a great tool. Some people will tell you that it's not a great tool. Some people don't like it because of the way it sheet loads. But some people might not like it because they haven't set it up. So this Fabricator wants everything set up in order of operation. So they want everything that is welded together, everything that's shop bolted together. That way when it's running through the shop, 1 through 10, all these pieces have to have shop welds. 11 through 20 are all shop bolted, you know, and then so on and so on. So by member type, what it's going to do is it's going to separate and put all the columns together, all the beams together, bracing together, and so on. I don't like the way it does the member type with SDS2. I'm picky on, I want all my columns together, but I want my columns first, and then I want my beams. SDS2 likes to go with beams first, and then columns, but I can't put a beam up unless I have the column up. I want to work ground up. That's how I like to do things. So I leave this on, but when I auto sheet load, I don't select all my pieces at one time. I select all my beams, all my columns, whatever I'm loading at that time. So this Fabricator wants to group all their members with like operations together. So is this member shop welded? If so, put them all together. Is it shop bolted? Put them all together. Are the ends cut or the flanges cut? So is this beam need to be bevel cut, or does the flanges have a bevel cut? And also members that are coped or have flange thinning. So is the beam coped? Is the flange, cut to 2 inches wide to avoid bolts? They also want galvanized together. So that will take all the galvanized items, put them all in sequence together, so that when they're running them through the shop, they can just grab, sheets 20 through 25 because they're all galvanized. So they don't worry about if the material weight and length. So here, you can include all your detail sub-material if you wanted to. We don't do that. We put everything on a gather sheet, one item per gather sheet. Then you get down here to, do you want to rotate your columns 90 degrees on the sheets? It is auto set to as required, or you can select always or never. SDS2 has a lovely issue of it will rotate your column 90 degrees even if it fits on your sheet. I hate that because I go through and I rotate them back around, but it's still quicker to use auto sheet loading than me do that. I could click never, but there are times that the columns need to be rotated. So this is a hard one to choose because I don't know exactly what it needs, I guess. So I just leave it, and when I'm scanning my sheets to make sure they all fit well, that's where I make my change. Rotate other details, beams, braces, 90 degrees on sheets. I like to say never on this one just because I don't want my beams rotated. I want my beams to look like beams. I want my bracings all laid flat. And typically rotating the beam 90 degrees isn't going to help it fit on a sheet any better. Minimum scale for member details. So I can come all the way down to 10% here, which means if that column won't fit, it will scale it down to 10%. But 10% is going to be really small. We set it to 40 on both of these. That way it will fit, and then we can adjust the scale as required. And then detail spacing isn't really affect this fabricator because we only do one item per sheet. So doing one item per sheet, I don't really care about the spacing. But what this is asking is, if you're putting multiple items on a sheet, how close do you want the members together? Do you want them almost on top of each other? Then you can say less. If you want bigger gaps, say more. So we have this all set up for the fabricator. We hit OK, and that is everything in the sheets and reports. So in our next video, we will dive into the detailing, which there is a lot in here. Some isn't nearly used as much as others, but I will say that concrete, rebar, crane limits, and appearance, we're not even going to look at those because I'm not detailing concrete, I'm not detailing rebar, and crane limits, that is kind of on the erector, not the detailer or the fabricator. There are times where we need to take that stuff into account, but not in setting up SDS2. So, thanks for watching today's video. We will see you next week when we jump into our detailing settings. Just a reminder, if you have any questions on SDS2 or still detailing, leave them in the comments,